All right, this is section 7.1, applications of right triangles. So number one, we're going to solve a right triangle. Letter A, what does that mean? So to solve a right triangle means to find the measures of its angles and sides, and of course we look for the missing angles and sides. Letter B, we label the vertices with capital letters, the vertices of the triangle, and the sides with lowercase in the following way. Side lowercase a is opposite angle capital A, side lowercase t is opposite angle uppercase T, and side lowercase z is opposite angle capital Z, and so forth, whatever letters are being used to name the triangle. Letter C, we use trig functions definitions to solve for the missing sides and angles, and we really only use the definition of sine, cosine, and tangent using a right triangle, like the sine of an angle is the side opposite over the hypotenuse, and so on. Okay, so let's do example D. It says solve right triangle ABC and round to the nearest to the 10th place if necessary. So we have triangle ABC with angle C 90 degrees, which means side C is the hypotenuse. And then we have the other two angles are A and B, and angle B is 54.2 degrees. All right, so the first thing we can find is angle A, because angle A and B are complementary, right? They have to add up to 90, those two. So we subtract 54.2 from 90, and we get 35. All right, so this angle A will be 35.8. I'm going to write it in the triangle itself. All right, and of course I can also write it outside. All right, and then I'm going to use a trig definition. So because I have both the acute angles and the hypotenuse, and angle B is 54.2 degrees, then I can start with that and say that the sine of 54.2 degrees is side B over 42, which is the hypotenuse. Okay, so to solve for B, then I multiply by 42, and I have B equals 42 times the sine of 54.2 degrees. All right, now that's an exact answer. That's an exact answer. If I need an approximation, I punch that into my calculator. Make sure you have your calculator in degrees. There we go. And I'm going to find the sine of 54.2 degrees, and then times 42. Okay, and I get 34.06, and it says to the 10th place, so about 34.1. All right, and these, there's no units there, so we don't need to write units. All right, we also know that angle A is 35.8, and we can find side A, right? So the sine of side A, of angle A is A over 42. So the sine of 35.8 degrees is A over 42. So A will be 42 times the sine of 35.8 degrees. All right, so that's an exact answer. And then if I want to approximate, well, then I punch that into my calculator. Okay, so I'm in degrees now. We need degrees, and I'm taking the sine, and then I'm going to multiply times 42, and that gives me 24.568, so about 24.6. Okay, so I have found everything I needed. I was missing angle A, I found it, side B and side A, and I found those two. Notice I have exact answers if I need them, and approximations. Exact answer and approximation for each one. All right. Let's try part 2, application. So you're still solving right triangles, and you may want to draw a picture. So let's try an example. A 40-foot ladder leans against the wall of a building, making a 20-degree angle with the building. How far up the wall does the ladder reach? So I'm going to draw first a sketch of this. I have a right triangle at the bottom of the triangle where the wall meets the ground, and the 20 degrees up at the top, and I want to find the length of the wall from the bottom to where the ladder touches. Okay, so then I know that the ladder is 40 feet. And the 40 feet is going to be the hypotenuse. So I have, relative to the 20-degree angle, I have the side adjacent and the hypotenuse. So I'm going to say the cosine of 20 degrees is h, so that's the side adjacent, over 40. And h is the distance that the ladder reaches up the wall. All right, so I just need to solve that. So h will be 40 times the cosine of 20 degrees, because I just need to multiply by 40 to solve. And that's an exact number. And if I need an approximation, and these are feet, right? So it'd be 40 cosine 20 degrees feet. And if I need an approximation, that'll be approximately, and I'm just going to punch it into my calculator. So 20 degrees cosine times 40. And I get 37.587. And of course I can round to wherever I'm asked to round. 37.587. I'm going to say 0.6. Right? Nobody told me where to round, so I'll just round there. And of course, if I'm asked for an exact measurement, it's 40 times the cosine of 20 degrees. And feet. All right. There's example 2 and example 3, which we will do in class. Let's go on to part 3 about bearing. It says compute the bearing of an object. So definition first, the bearing from point A to point B is the degree measure of the angle of the acute angle formed by ray AB and the north-south line. And we say it in the following way. A bearing south 40 degrees west denotes a direction 40 degrees to the west of due south. Okay? All right, let's try an example. A boat leaves a dock heading north 27 degrees west. So from north 27 degrees west at 6 knots, or nautical miles per hour. Determine the number of nautical miles north and the number of nautical miles west that the boat travels in 0.5 hours. Oops. Round to the nearest tenth if necessary. So 0.5 hours means it traveled three nautical miles, but in a diagonal, right? So I'm going to draw a picture. So again, I'm going to draw the north direction. So from the starting point, the north direction. I don't need the south because it's not mentioned at all. All right, and then from there, west 27 degrees. So that's where my boat went. And then I'm gonna, I drew a line that represents the distance my boat went, and it went 3 nautical miles at an angle 27 degrees west of north. All right, so I'm gonna complete a right triangle with where my boat is at this point after 0.5 hours. A horizontal line to the north, to the line that goes north, and then makes a 90-degree angle. Okay, and now I have the north component of the distance my boat traveled and the west component. I'm going to call the north component y and the west component x. Okay, so and the angle 27 degrees is right at the vertex where the starting point of the boat is. So at this point I have a 27-degree angle, a hypotenuse of 3, an adjacent angle of, an adjacent side of y and an opposite side of x. So I'm going to say the sine of 27 degrees is x over 3. And so x is 3 times sine of 27 degrees. Okay. And I also have that the cosine of 27 degrees is y over 3. So y equals 3 times the cosine of 27 degrees. All right, so I have exact answers, and this is round to the nearest tenth if necessary. So if I need to round, then I just need to multiply, let's see, 27 sine times 3, and I get 1.36 approximately. It says round to the nearest tenth, 1.4 nautical miles. And the other one, 27 cosine times 3, and I get 2.7. So x is approximately 1.4, and y is approximately 2.7 nautical miles. All right. That's section 7.1, and we'll put 7.2 on a different video.